Hello, I'm Brian Gleason. I'm going to be your guide through productivity tools, helping you get programs to the floor faster. A little bit about myself. I'm a Mastercam applications expert out of the Phoenix, Arizona office. Been in manufacturing for 20 plus years. Wide range of different fields I've been working in. So, our agenda. Today we're going to talk about integrated probing in Mastercam, simplified curve and Swarf toolpaths, fixture design for large parts, a little bit about Deburr, maybe a few uses that aren't thought of, getting into import export, and then we'll also do a little Q&A at the end. So let's get started. First thing first, integrated probing with CIMCO probing. I remember I used to have to write a program, go to the floor, call it up on the VQC, wherever your machine was doing, and then have it export into the program. Things happen. If I had to repost the program, I'd have to do that all over again, or I would also have to go ahead and hand edit and place them in there. What we can do is have that all in the Mastercam file. So what we have here is I have finished part, and I want to add some probing into it. So I'm going to move my insert arrow up. We have this tab I created, CIMCO probing, and the first thing we're going to do is going to do an alignment. Now this is a 3-axis machine. I'm just showing this sample to give you an idea how it would work on a 5-axis to be able to line up maybe your C-axis or something like that. First thing first, I need to add a tool. Go to my tool manager. I don't have anything in my library, so I'm going to switch my library. And if you ask so kindly, later after this, maybe I'll offer this up for you, but we have a CIMCO probing with the LMP40 tool database. I'm going to use my 3709, which is my standard overall length and diameter. It's going to be that 236 6mm ball. So we have our tool. I'll go into the cycle. I need to let it know what we're doing. We're going to do an alignment. I'm going to select the line, select our plane, and I'm going to say we're doing a positive touch. Give it some dips. We get a nice little preview. I'm going to rotary line up for, the rotary axis name, C, for work offset G54. And voila, we have our first probing. Next, I'm going to probe the top for Z. So we go probing, workpiece datum, and 0.1 axis. I'll select our tool, cycle. I need to tell it where to go. Come down on the origin, set in the plane. Measuring height is going to be 0, and then I'll add some clearance heights. And what we're not seeing is it's populating, but I have my axes showing. All right, we have it now probing the top to locate the Z. I'm going to have this based off the center of the part. I want to locate that. I want to double check something, make sure I do have my stock is set up. So we'll go to a probing, workpiece datum. I'm going to do rectangular outside. Have our tool in there already. Cycle. I'm going to right click, and I'm just going to say from stock. Set it to the top plane. And voila, there's our locating set in G54. The reason this one populated first is because I saved the settings. Oh, cool. So got it lined up. We have locating the top and the XY 0. We'll run the part. And after I run the part, I'm going to check a few features. So we'll do workpiece inspection. I'm going to do rectangular outside. Select my lines. and I'm just going height and width, setting the top plane, and I already have these saved in here. So now I'm probing the rectangular portion of the profile. Now, if I wanted to save this, I could go and say, let's do actual height. I'll save that as macro variable value 1000. We'll do the height. Sorry, said the width on the for the height, and we'll save those out. And if I wanted to, I could refer to those and make sure everything's looking good, or I can deprint that out if I wanted to. Lots of different options to do with that. Next up, I'm going to do the inside. So we'll do another workpiece inspection. We'll do rectangular inside. Same tool. Right click, selecting the lines. So I'll go width and the height. Need to tell it we're going to go 1/4 inch deep. Add some clearance. Again, I could save those results if I wanted to. So we got the inside outside probe. All right. Next, I want to probe the little diameters on the outside. I'm going to do another workpiece inspection, and we're going to do diameter outside 3 points. Same tool. I need to select my arc. And I can go and select more arcs as I want and do it all in one toolpath. So let's look at the first arc. I'm going to give it a measuring height, minus 1/4 inch, clearance 1/4. Awesome. So we get a nice little preview. And if I wanted to, I can change my first angle. I'm just rotating my mouse wheel, so I can change the angle of where it's actually probing at. Or you can just type and it will change. So some cool features. Now, I would have to go and re-input the values for all these. So let's look at this guy first. I'm going to save these. So save. Need the height, distance, clearance. Turn everything else off. I'm going to delete these guys. And we'll go add the other arcs. And now that I saved everything, it's coming in a lot quicker. Awesome. I'm not going to mess with the angles on these other 3 diameters. Pretty good. Pretty confident they're going to be all right. A little green check. We have our probing toolpath. If we wanted to, we can hop on in to verify. We'll expand that out. And I'm going to slow it down for a little bit. And we can see all the motion. I didn't slow it down quite enough, but we're going to be able to verify that probe and make sure everything looks good. So nice feature about that. I don't have to do any guesswork with by hand editing. Alrighty, now it's fine and dandy to probe those diameters, but let's do something with it. On this first diameter, I'm going to turn on some if-thens. So first one, scrap. I'm going to do a manual entry. I'll say pound 3000 equals 1. part is scrap. So what this is going to do is put the machine in alarm state with the message part is scrap. Remachining, I'm going to tell it to go to an operation, and I know my first finishing contours is op 6. If it's within tolerance, I'm going to tell it to go to program end. So now we can come down here, and I'm going to set a greater than or less than, and let's just say it's plus or minus 2 thou. Now we can do more. I'm going to say update the tool offset, automatic. So if I'm undersized, it will go modify the tool offset, go to the remachine. If I'm oversized, it's going to alarm out, and if I'm within tolerance, it's just going to go to the end of the program. So got that going, regenerate it, select everything, we'll post out the code. Looks like I've done this before. And looking at, we have our locating, and then we'll touch off the tops, do the outside, but I don't have to manually put those in. There's the actual program. Zoom through that, and then we get to the end. It's going to start probing, and then we have our if-then statements. So lots of cool options inside of there. I didn't have to manually write anything. I didn't have to go put it in. Now let's look at some other benefits. It's going to be a lot quicker. I can prove it out in Mastercam. Say that we lose the program and I have to repost this all. It's already, all the probing routines are already in there. Other benefits about the CIMCO probing. It's going to piggyback off the probing cycles that are already in there, so implementation is a much faster, easier. It's already just using what's on the machine itself. This post is referring to the hot Renishaw. If it was set up that we support Marpost, we support Bloom, so whatever probing system you have, it's all supported through the CIMCO. So awesome. So again, super simple, easy to do, and saves you time not having to hand edit it on the floor. Next thing I want to talk about is design tools. So it used to be called Mold Plus, but they would change the name. I guess design tools sounded easier, and it's a add-in. But it has some cool features. I have a tab here for design tools. There's all kinds of options inside of here. You can create 3D edges. You can do electrode makers, trimming, extending, bunch of different 5-axis toolkits. We're going to focus in on 3 features of this one. First one being edge pass or 5-axis curve. Now, say I have this form part, and I have a bunch of edges that might be a little deformed or anything from the forming process, and I need to come and trim all those toolpaths. Now, I'd probably have to come. I would have to say something like line normal to, and then place out a bunch of vectors, and then tilt those vectors. And I would have to do that all the way around here, and it would take me quite a while. The design tools, well, I'm just going to do a quick edge path. I pick an edge, and we're already starting the toolpath. I can click the start, say I want to go just that section. I don't have to go all the way around. I can change the direction, or I'll just do a full pass. Happy with that. I don't like the cut direction, so I'm going to reverse that. cool. I need to add a tool, so I'm at my little lightning bolt. It's going to pull up library. I'm going to say 1/4 inch flat end mill because everybody has one of those. We can simulate this. So as I'm coming around this angle, I see a tilt in back and forth. Let's see what this corner looks like. Tilt, not too bad. Seen worse. Coming around the back side. And on this section, I don't like those retilts going back and forth. So close out of there. Let's see how we can fix this. So like I said before, I would have to go modify each one of these vectors, which is nice that the design tools is drawing up the vectors for me. But since I'm still in the edge paths, I can select the vectors I'd like to modify. I'll say interpolate vectors within range. It smooths those out. We'll smooth this one out. Again, I'm going to smooth out this section. I think going around the back was good. I'm going to smooth out this section. And where else do we have? Oh, yeah. Awesome. Smooth that all out. And go back. And I can simulate that. So get it to simulate it before I actually finalize any toolpath, which is kind of nice. So that looks a lot smoother. This section looks smoother. And then we'll go around the back and see what that looks like. And voila, I'm happy. Now, probably don't want that tool cutting right on top of there, so I'm going to tell it we're going to do a side offset, and we'll cut a little bit past the bottom. We'll generate that. Tool is corrected. Letting it do its thinking. And what we're going to see is that it created a 5-axis curve. We can backplot, verify, whatever you want to do with that. And we'll get to see nice smooth tool motion. Awesome. Now that I get it all trimmed up, how am I going to support that part? I could do a negative and post it all out and then have to surface the whole thing, or we have another option with inside the design tools. I'm going to do a grid fixture. I already have my spacing plotted out, and over here we have what's called the plate fixture creator. So again, since I already laid out, I'm going to select my layout lines. I'm going to use my quick mask real quick. And voila, we're going to start building up our support fixture. So we're going to add slots, so that way we can slot them all together. I'm going to add a chamfer to add a little clearance to it. Free space, I'm going to clear up some space so when I tilt around, I'm not going to run into my fixture. Do we want a base plate? Yeah, I want a base plate. Scallops. So this is going to go along and reduce as much contact point as possible. In cutouts, I'll add those just to lighten up the part. And our tolerance. Pretty happy with that. Pretty quickly, easily designed up a fixture. Well, we have to make the fixture, so I'm going to say go ahead and create geometry. It's going to create another level. And I can see everything is nested, well, not nested, everything's laid out and labeled, so we can come back. You can program it on your water jet, whatever you're going to use to cut it out, or even if you had a piece of sheet metal you wanted to run on the mill, able to do it all super quick and easy. So definitely some nice features in there. All right, moving along. We're going to look at Swarf Toolkit. Now, say you only have the curve drill 5-axis option, not the full multi-axis. The design tools is going to help you a lot. So beyond just going and doing trimming, I can do a quick swarf on this path. So we'll go swarf pass. I'll select the wall. We can move our start. Well, we'll just keep it going all the way around. Oh, too far. Now it's going in a good direction, so I'm happy with that. It's already creating all my tilt lines. We'll need to add a tool. I'm going to modify the settings on the tool. Cut a little past the bottom. We can simulate that if we want in here. I'm happy. I can green check, go to my toolpath manager, and it's going to give me that toolpath. Now that I can fully edit this, if I'd like, we can do, maybe we wanted to add an entry exit on there. Now let's just say let that regenerate. Oh, not quite enough on there, huh? Well, that might help if I had the right settings. There we go. So lead in, lead out, quick and easy swarf toolpath. So what's the benefits of this? Super simple, quick fixture design. Easy to manage the vectors on the edge paths, and then it's a pretty quick, simple way to create a swarf toolpath as well. Moving along. Deburr in 3-axis. So the Deburr toolpath is always thought to be just multi-axis, but we can use it in 3-axis as well. So maybe we had multiple setups. We don't have a multi-axis machine, so we have to do it on 3-axis. I have a setup and I drill this cross hole and I come drill this cross hole, but I want to break the edge of that intersect. Now, traditional easy would be, I'm going to break the edge on top, just do my good old model chamfer, select my edge, select a tool, and we'll say we're doing 10th thou, and I like top clearance, top offset better. Awesome, broke that edge. Now what about the cross hole? So if we go into our multi-axis Deburr, I'm going to use my lollipop tool, set my cut pattern, select the whole part, and I'm going to tell it exactly what edge I want to cut. I'm going to add a little clearance, add a little old manager say it misses a mile, so one without clearance should be fine. Let that generate, and voila. Able to get in close, break the edges of that cross hole. Saves me time. I don't know if everybody has a deburr department, or if it was just you setting up the machine deburring parts. I'm going to let the machine do it. So hopefully just a quick idea on other uses. I guess we got one more sample we could take a look at. Honestly, we're going to use the lollipop tool, cut pattern. And I always like to tell it exactly where I'm going. So break the edges. Again, I'm going to reduce this down a little bit just to make sure I can get all the way in there. And test the Becker factor of your operator. So maybe we started off on a 3-axis machine, but we can always come back and change this to 5-axis. Let that generate and be able to break all the edges. So we can break it on a 3-axis machine, we can break it on a multi-axis machine. So it's a very versatile tool. So just super easy to use. It's going to save you time in the long run, less handling, so you're not having to do as much work, less chance of error to gouge apart with your file or something like that. Cool. Next, what I want to talk about is import-export of proven toolpaths. So I'm going to look at, I have this part here. So I have all my roughing operations, I have my finishing operations, and I have all my drilling and a deburr. We proved this out, went corrected speeds and feeds. Everything's working good for this material. Everything's dialed in. My tools are all inside of here. We're good. Now, a couple things we can do. Me personally, I like to export out tools, and I would save it to a different file. Let's just go here's my roughing. I saved it into a folder for steel. I'll export those out. Nothing changes in this file. So that's one way I would do it. I'm going to look at this other part we have. We have no operations, and we have nothing in the Toolpath tool manager. Let me set up my stock real quick. Oops, forgot to hit one little button. We have our stock set up. Cool. I'm going to bring in some of the operations from that proven part. So, two ways to do it. Right click, import, and navigate to where I know that proven part's at. Change my selection filters to Mastercam part files, and I can bring in the actual roughing toolpaths. I can select which ones I want, import them in. Awesome. So what we're going to notice is our tool manager brought in the tools, It's going to keep the same speeds and feeds that were used on the proven toolpath. And let's go see how quick we can get this done. So we have that hole. I'm going to set my linking parameters. We set our geometry, so I'm going to say from outside of void. Set my linking on this. And I'll just go to the top. Let that one generate. We need to add geometry to this guy. Set our depths. So we have that all roughed out. This guy we're gonna say stay inside, machining regions. I'm gonna do cavities blind, select this face, get those real quick. Set my linking. And voila, we have everything roughed out super quick. Now, I don't need to only import, export parts, complete parts, family parts, or anything like that. Let's look at these holes. Say I have a saved process for that. So I'm going to come, we'll do import. I'm going to go to my feature folder where I have all my operation libraries that I customized. I'll go to steel, and I have my 3/8/16 tapping routine. We'll bring in our chamfer drill and our pec tap, rigid tapping, and then select them all, import them in. Awesome. Again, we're going to see that it brings in the tools needed. We just have to apply geometry. So let's make sure don't have anything crazy coming in. There's the first holes. I'll regen that. It's spotted. I'm going to take this geometry, copy it down, pec drill, regen that. It's drilled. We'll take this geometry, copy it down to the tapping, regenerate the tapping, and we now have everything spotted and drilled in a matter of seconds. So let's talk about some benefits of this. We're not reinventing the wheel with every start of a new part. We're going to have more consistent first parts, so more faith in your operators as well. And we're going to have a lot less time programming. In a previous life of mine, I was one programmer for 30 machines. I had to get very efficient at programming, so I saved a lot of routines or family of parts so I could get through that super fast. So hopefully this is going to help you be more productive at work. So thank you very much. We're going to go ahead and we can open it up for questions. And thank you again.